So I recently got asked how Slicer runs so well on my computer, and if you just need super expensive hardware to get it to work. So I thought because this is not the first time that I've gotten that question, it would probably be worth making a video about what you do need to spend a little bit of money on and what you really don't. Um, and in fact, I'm happy to say that you really don't need super duper high end equipment, and it may actually surprise some of you that I have been recording all these videos off of a laptop, as you can see. So hopefully this just shows you up front that although this is a pretty, nice and expensive laptop, it is not the super duper high end equipment that it may seem like you need to get started with this type of data. All right, before I get into specifics like what kind of RAM or graphics card you might want, I wanted to go through some of the sort of basic choices you need to make as you start searching for a computer that can run this type of software. The first question that can come up would be, do you want a Windows or a Mac? To be honest, either should work. Most 3D software runs on Mac. So really, it's down to your preference, with the caveat that you should check compatibility if you're thinking about a specific software that you might be worried about. I personally prefer Windows. I find it to be a lot easier to troubleshoot, and it also tends to be a lot cheaper. You get more bang for your buck in terms of computing power. The next question you might want to think about is whether you want a laptop or a desktop. And this basically comes down to whether you need the portability of a laptop. So the reason I have a laptop is because in grad school, not only was I going between working from home and working at school, but I also did a number of museum visits where I was running photogrammetry on my laptop, and being able to do that at the museum was necessary. But if you do not need that kind of portability, a desktop really is the way to go. For one thing, you can get more power for the same amount of money. And another really big advantage is how modular desktops are. So if you say buy a base model and then realize you want more RAM so that Slicer will run better, it's pretty easy and pretty cheap, honestly, to buy an extra stick of RAM and just stick it in your desktop, assuming it has open slots for that, which oftentimes they do. The final question that might come up is whether it's worth building your own PC. That can be really nice because it lets you really customize what you need. It's often cheaper because you're buying and assembling the parts yourself. The only thing I would caution on is that you need to be very careful about part compatibility. So I can't go into too much detail because I've never done this myself. I'm quite frankly scared that I'm going to break something. But I do know that, certain motherboards won't be compatible with certain processors, and even like the power source needs to be compatible with the motherboard or whatever other parts you have. So my suggestion would be, honestly, to find someone who's done it before and have them help you. You could probably also really thoroughly research online, but that would be my recommendation, would be to find someone who has experience with that. All right, so now let's talk about the actual specifications you'll want from a computer you're searching for. All right, so let's start talking specific specifications that you're going to want to look at. I'm going to be showing my husband's desktop as an example because it's a lot easier to see the components in it, so you'll get an idea of what these things actually look like. All right, so this is what the inside of that desktop looks like. It has a very nice, pretty glass panel on the side, so you can see all the different components. And apologies, this isn't a video. It turned out the glare on it was a lot harder to get through. So I've got some pictures to show. So the immediate thing to catch your eye is something that's kind of standard in a lot of just pre-built gaming computers now, which is RGB lighting to make it look very cool. These are all just fans that are being lit up, because one of the things that ends up happening with powerful processors and graphics cards is they get very hot and they need to be cooled down. So these are just a bunch of standard fans to prevent this computer from overheating. My laptop also has pretty powerful fans, but that's another kind of laptop trade-off, is that it's a lot harder to cool. Okay, but let's talk about the components you actually need to worry about. And what you're seeing is essentially this circuit board on the back is the motherboard. And then all of the core components are plugged into it. So behind this fan is the CPU. That's the central processing power of the computer. Next to it, we have these 2 sticks of RAM, which is like the short-term memory of the computer. And then this huge thing down here is the graphics card. Let's look at this from another angle. All right, so it's a little easier to see my components now. Here are those RAM sticks again. So RAM is the first thing you're really going to want to think about. And RAM is like the short-term memory of the computer. Basically, anytime you're running a program, or even just the operating system running, is going to take up some of your RAM. Essentially, the computer has to have that to load in things like the graphics that it's showing you and all the data that it's using in that program. So if we're thinking about a normal laptop, you usually have about 8 to 16 gigabytes of RAM, and honestly, that's fine for most really basic computing things like web browsing or word processing. If you're doing 3D data, I recommend an absolute bare minimum of 16, and every other computer I work on has 32. And I think 32 is a really good medium between being more than your sort of normal computer and having a lot of extra space, but not being so much like 64 or 128 that you get with the really high-end computers. RAM's not that expensive to upgrade though, so it should not be that much more expensive for you to jump from a 16 to 32 gigabyte RAM computer. What makes it expensive is the sort of processor and graphics cards that are needed alongside that. All right, let's talk graphics cards. This is probably the single most component of the computer if you're planning on working with 3D data, and it's optional in most computers. So to explain, what a graphics card is it's just a dedicated processor specifically for rendering 3D graphics. And because of that, it's really not needed in most base level laptops because most of the time you're not doing really intensive graphics rendering. In those laptops, you'll have what's called integrated graphics, where there's a little part of the CPU, the central processing unit, that is dedicated to whatever graphical rendering needs to happen. And in fact, if you're looking at a laptop, I kind of just picked this one at random. Often you'll see it say something like this under graphics. This Intel Iris Xe graphics, that's just integrated graphics, a little dedicated part of the CPU. My recommendation for if you are doing anything with 3D data, the base level is just to make sure there is a dedicated graphics card in it. Okay, often what that will look like is something like this. So NVIDIA is the most common brand of graphics card. So you'll probably see NVIDIA GeForce and then a number after it there. So base level, make sure you have a graphics card. They tend to be the most expensive component, but even a low-end one is really going to up how well 3D programs run on your computer. If you have some money and you want to get something that's going to run a little bit better, I'm really only familiar with the NVIDIA series because that is by far the most common one in most pre-builts. But they go from this GTX 16 series, which is what my old laptop had, I might have actually even had an earlier one, but that's really the lowest level. It's going to be the cheapest. And then just as the numbers increase, the graphics cards get better. This laptop actually has a 20 series, so it's really not, it's a dedicated graphics card still, but it is not a super duper fancy one. And it's the 2070 Super, so it's basically a laptop version of the 2070 that's a bit smaller and fits in here. And what you can actually see from this is that the GPU, as I'm monitoring it, it is running some things. That is my screen recording program, actually, that I think is taking up most of this right now. But if you want to know the specific stat to care about, it's going to be the amount of GPU memory. So this card has 8 gigabytes. So basically, it's providing a dedicated 8 gigabytes, extra 8 gigabytes of RAM for specifically 3D rendering. Sometimes you'll see this listed as like VRAM 2. Bigger number is generally better. But honestly, in my experience, like as long as you have a GPU, you're probably going to be able to do most base level 3D things. Okay. The last thing I want to focus on is just the hard drive. So on this, back on my husband's computer here, you can see this little stick stuck to the motherboard right here. That is the hard drive. These are solid state. I think there are 2 there. And it's a solid state hard drive, which means it's kind of like a USB stick, essentially. The only recommendations I have with hard drive is just more is absolutely better. I have never had a computer that I have not filled up space on, and because I've had laptops, I've generally had around 1 terabyte of space. You can buy external hard drives to increase your space. You can swap out hard drives for bigger hard drives, and this tends to be something that's not as expensive as the GPU. There is a difference between running off of a sort of traditional disk hard drive and the solid state. A lot of computers, at least in the past, I guess I don't know now since I haven't bought a computer in 3 years, but you would get computers that would have a sort of big disk hard drive that was maybe like 5 terabytes, and then one that was 1 terabyte or even less for running the operating system, a solid state. That was 1 or less. Basically, solid states are just faster to run things off of, but I don't think it's nice, but it's definitely not a like absolute need if you're just getting started. The other thing you might wonder about is if you need to worry about processor or motherboard, anything like that. And my experience is that as long as you're getting the amount of RAM you need and you're getting the GPU you need, the graphics card you need, if you're buying a pre-built computer, the CPU will work plenty fine. So really, I would recommend just focusing on those 2 specs, and the other sort of components of the computer should line up with that. All right, let's talk about the accessories you want if you're going to be working with 3D data. I only have one that I think is required, and then I'll have a few that I think are nice. My required accessory is a 3-button mouse. So a 3-button mouse is just a mouse with a left click, a right click, and then a scroll wheel. Most 3D software rely on you having that scroll wheel. Fortunately, of course, a 3-button mouse is pretty cheap. You can get one for like 10 or 20 bucks. And this is also if you're on Mac too. It still is pretty necessary to have a 3-button mouse. This one's a bit fancier. It's got a little keypad on the side. You can assign different key bindings to this, and it can make it easier if you're working a lot with certain shortcuts. To be completely honest, I only use it for playing games. I don't really use it for working with 3D data. Okay, so that's my only required option, but there's a lot of other accessories you can get if you have a little bit of money for it, that can make your life a little bit easier. The first one I have here is a Wacom tablet. Um, this was about $70 when I bought it. Basically, it plugs in the computer, and you can use a little stylus that comes with it to draw on it. It's really nice if you're segmenting. I believe I mentioned it in the segmenting video as well. And it's honestly not too expensive to invest in. And there are computers that you can get that have a touchscreen monitor that you can draw on a stylus with. I found this actually works better, and those monitors are way more expensive. And it's because your hand gets really tired if you're got your wrist up here all the time, but this is just drawing on a normal piece of paper. It just takes a little bit of getting used to drawing and then looking at the computer screen for the drawing. Another accessory that may or may not be necessary depending on what computer you go with is laptop specific. This is a cooling pad. Essentially, the holes you see in it are have fans underneath them, and you plug the USB into the laptop, put the laptop on top, and the fans will blow cool air directly into the laptop. Again, a thing I got because I was playing games on a laptop on my lap. But if you're finding you have issues with a laptop overheating, this again is not super expensive and it could save your computer from overheating. And then finally, I just figured I'd go through my docking station setup. So I have the laptop to work off of because I needed to move around a lot, but I also really like having a more a bigger setup to work with when I'm at home. So I have this docking station and an external monitor. And really, I do think dual monitor setup, either a laptop screen and external monitor, or two monitors if you've got a desktop, is borderline necessary at this point, but most people have that, so it's pretty common. And then an external keyboard is the other component of this. All right, one final accessory that absolutely falls in the fun but not necessary category is a VR headset. So the advantage of getting a VR headset is it's kind of a cool outreach tool. It's also, there is something very fun about being able to see the things you're working on in a very like hands-on feeling, interactive kind of way that you don't get as much with a mouse and keyboard. But of course, this is really just a kind of fun thing and not at all necessary if you're just getting started. All of this setup in particular I have is the Index, which is sold by Steam. It was about $1,000, but there are cheaper alternatives. I believe the Oculus Quest 2 is only around $400 or $500, and it hooks directly into a computer. So if it's something you're interested in playing with, I would say the real advantage of it is if you're really interested in being able to see things at scale. So one of the coolest sort of VR uses I've seen at a conference was someone who had a photogrammetrized an entire site of a beached whale. And so you could actually see how huge the whale was in comparison to yourself. But again, not by no means necessary. And I forgot to mention at top, but I will link all of the products I mentioned specifically in the description. Not even so much as recommendations for you to buy specifically, but just so you can see what I've been working with and kind of compare prices and figure out what's going to be the best option for you. Okay, and I wanted to end on some troubleshooting tips. If you are running out of, if you feel like your computer isn't running as well as it should be, or you feel like you just don't have enough power, you can change some ways of how you do things to work within the power that you have. So the first thing I'm going to point you to is the ImageStacks video I made a couple months ago. If your scans are just too big for Slicer, this is a really awesome way to crop and downsample them so that they're a smaller size, but you can still work on what you need to work on. Especially for 3D rendering, you really shouldn't need the super high resolution version of the scan. This has been downsampled to 100 microns and it still renders great. So keep that in mind. You really don't need to render the full version. And you can crop to specific areas if you need really high resolution data. The other recommendation I have is sometimes you might start having problem with 3D rendering even though you do have a dedicated graphics card. I speak from very recent experience on this actually, and this has happened to me multiple times where you might notice that even though you have a dedicated graphics card, your computer has decided to still run everything off of the integrated graphics. I may have forgot to mention, but even a computer with a graphics card will still have integrated graphics on the CPU. So this is Windows specific. I unfortunately don't know what you would do for Mac for this, but the first thing you should do if you're having trouble with anything 3D data-wise is open up a task manager. It'll open on processes, which says everything you've got running. Go over to the performance tab, which is going to tell you all the resources that are being used. So for instance, if RAM, which is also called memory, was up at the ceiling here, I would know I'm maxing out on RAM and that slicer was probably going to crash on me and that I needed to do something about my data. Down here, you'll see I've got 2 GPUs. This is the integrated graphics. It's called Intel UHD, blah, blah, blah. And there's some stuff running on it right now that should be just the general rendering for like the web pages in my computer background. And then I've also got some stuff running on the actual GPU, which is the NVIDIA GeForce. I've experienced where I've tried to run, say, the VR headset, and it is entirely running off of the integrated graphics. And my nice fancy GPU is sitting here running nothing on it. So that is a really good red flag for you might not need a more expensive computer, you might just need to adjust some settings. So when that specific problem happens, when you see something's running off integrated graphics and not the GPU, you'll want to go to graphics settings in Windows, and you'll want to make sure that the program you're running is specifically set to run on your GPU. So in order to do this, you'll need to browse and select the app to add it to this list of specific settings. And then once your app is on here, you can adjust whether it runs on the integrated graphics or the GPU. So let's just look at the VR dashboard since it's already on here. So I click on it, I click on options, and you'll notice right now, Windows has decided it should run off of the integrated graphics, which is bad because it's not going to run well at all. So I want to switch it to the dedicated graphics card, which in my computer is this NVIDIA GeForce RTX 2070. I want to save that. And now, if I were to run my VR headset, it should be running off the actual graphics card. So that's just, there's a few other things that may come up. That's the most common problem I've experienced when my computer isn't running something in the way that it should be. One thing I forgot to mention earlier for troubleshooting, sometimes your devices might not be plugged into the right port because there will be HDMI and display ports that plug directly into the CPU and ones that plug directly into the graphics card. So I'm going to show, so here you see the graphics card here, CPU is up here. If we look at the back of the computer, there's an HDMI cable port up here that plugs into the CPU, and then there's display ports down here that plug into the GPU. So if you're finding that you have a GPU but nothing's running on it, especially if you're plugging in something like a VR headset, it's worth checking to see whether it's plugged into the correct port. And specifically, is it plugging directly into the GPU or is it plugging into the CPU? Probably won't be an issue for most people, but just something to keep in mind. All right, so please leave questions below. I can't promise I'll be able to answer them all since I am not an expert um, in computers specifically, but I hope this helps you start thinking about what you want to do with your 3D data and what kind of hardware you need for that.